Hello everybody, this is Unit 1, Day 12, okay, our last unit in this chapter. So what we're going to be doing, all right, at least for this assignment, is I'm going to do all the odd problems, and you are going to do all the even problems. Okay? So that means I'll have 1, 2, 3, 4, 5, 6, 7, 8 problems to go through. Okay? So we'll make this short and sweet. All right, so let's get started. So in this first piece, okay, I notice I have an x plus 2 and an x plus 2 on either side. All right, which means, kind of like if we had 5x minus 5y, right, I could take out a 5 here. Well, same thing goes with this number right here, right? I'm calling it a number because if we had a value for x, it certainly would be, right? So, what do I see on both sides? An x plus 2, so I'm going to factor out that x plus 2. Make sure to put that in parentheses. And by doing so, I'm left with x minus 3 minus 2x minus 5. Okay, my next step, I'm going to distribute this negative sign. So this becomes a plus, that becomes a negative, and that becomes a plus. Now I can get rid of my parentheses. I will combine like terms. So I get x plus 2 on the outside, and then x minus x gives me a negative x, and 5 minus 3 gives me a positive 2. And that is our answer. Okay? Let's go to the next one. So the next one, all right, this is an example of a difference of perfect cubes. Okay, so I know 125 is just 5 cubed. And I'm going to put that m right there. So I'm writing it like this so it makes it a little more clear on what our a and b value is. Remember, this formula is found by a cubed minus b cubed is equal to a minus b, a squared plus ab plus b squared. Okay, so that is our formula for that, which means our a value here is 5m. And our b value is 4. So I go 5m minus 4. And then parenthesis, 5m squared plus 4 times 5m plus b squared, which is just 4. So I'm going to simplify all that. So I get 25m squared plus 20m plus 16. That's our answer for number 3. Let's jump down to number 5. So our first step, all right, if we can, and don't forget this one, it's very important, is we want to look for a GCF. Okay, so in this one I do have a GCF, right? I'm going to take out a 2x to the third. By doing so, this is x to the fourth minus 8. Oh, not 8, I'm sorry. Well, 16. Whoops. I was thinking something else. All right. Now, we're not done here yet. Okay. This is a difference of 2 squares problem. Right? Which means our formula is a squared minus b squared is equal to a plus b, a minus b. All right, so in this case, our b value is certainly going to be 4, right? The square root of 16 is 4, but our a value is actually going to be x squared, okay? If you want to know a little tip, as long as this thing is even, divide it by 2, and that will be what you will put in your a value, right? So in this case, we'd have 2x cubed. We'd have x squared plus 4, and x squared minus 4. Oh, gosh darn it. Guess what? We are still not done yet. Okay, difference of two squares. So we keep going. 2x cubed, x squared plus 4. Can't do anything with that. And x plus 2, x minus 2. And there's our answer. Fully factor, which is what the direction says. Factor the following completely. Okay, so I'll let you try 2, 4, and 6 on your own. Let's move down to number 7. Number 7 here, okay? We are subtracting two rational expressions, which means in order to do so, we've got to come up with a common denominator. The first thing you want to do is you want to kind of simplify these denominators where you can. All right, so I see this guy right here. All right, I know this can be factored to an x plus 3, x minus 4, right? 3 times negative 4 gives me a negative 12. I add those two together, I get a negative 1, and so those are going to be the factors of x squared minus x minus 12. Okay, on the other side, before I can even talk common denominators, I need to make sure everything's factored in the bottom. This will make things, a lot clearer as far as what I need to multiply on either side. So as you can see, all right, this has got a bunch of missing components. All right, I see an x minus 4 on both sides, so that's going to stay. All right, so x minus 4 is definitely sticking around. All right, but what am I missing on either side? And actually, let me move this over. All right, well, on the right side, we're missing an x plus 3. And on the left side, we're missing a 3, which means in order to fully have a common denominator, I need to multiply by all 3 pieces. All right, so which means this side is also going to be x 3 times x minus 4, x plus 3. All right, so now I need to multiply with whatever pieces we're missing. So in this first piece, this first expression, we're missing a 3, so I'm going to multiply the top and the bottom by a 3, or 3 over 3. So in this one right here, I get a 9x plus 9. And on this side, I'm missing an x plus 3. So I'm going to multiply the top and the bottom by x plus 3. Distribute that 5. So I get 5x plus 15. All right. Before I do anything else, I'm going to distribute this negative sign. So this becomes a plus, this becomes a minus, and this becomes a minus. All right, so I just distributed that negative sign, and now we just kind of add as is. Right, so 9 minus 5x is a 4x. 9 minus 15 is a negative 6. All over 3, x minus 4, x plus 3. All right, I'm going to take out a 2 here. No, and I guess I was hoping for a cancellation, but we have an x minus 3 in the top and an x plus 3 in the bottom. Oh, I didn't factor that completely right, did I? This is going to be 2x minus 3. There we go. All right, and this guy is fully factored, so we're all set there. All right, let's go down to number 9. Number 9, all right, we're adding these two guys. So first thing I notice is that we're missing a 2 over here, right? So I'm going to have to multiply the top and the bottom by a 2. All right, and then also I want to incorporate the max amount of each letter that we see. All right, so I see 1x here, and I see an x squared there, so we're going to have 2x squared be part of our denominator, right? We need to account for that maximum amount of x's there, right? So on the left, I have to multiply also by an x. Now, that will take care of the left side. On the right side, all right, you'll notice that we're missing this y here. All right, so the only thing I got to multiply on the right side is a y. All right, and so our denominator is going to have to be 2x squared times y. All right, so on the left side we get a 10x. On the right side we get a 7y. Add those two things together. And voila, we're done. Okay, let's move on to number 11. Number 11, all right, oh, sweet. Look at what we're doing. We are just multiplying. Yes, finally, a nice problem. All right, so let's get to some cancellations here, right? Because we got nothing but factors here. All right, I only see multiplication up in the top, so I'm just going to start canceling things. I'm going to cancel this 2 with that 6. It becomes a 3. It becomes a 1. I'm going to divide both of those by 4, right? So that becomes a 1. That becomes a 5. So that takes care of the numbers. I see a z squared. So I'm going to take care of one of those z's up there. I don't see any x's down below, so I guess that guy will stick around. All right, and then on the other side here, I see 1y on the top and 4 on the bottom. So that becomes y cubed. And the only thing I got left on the left expression is that x squared. Finally, I can multiply these guys together. So I get 3x cubed times z all over 5y cubed. We can't simplify it any further, so we're Gucci. All right, good to go. All right, let's move down to number 13. Okay, so this one looks like a beast, right? All right, you're going to have to take it in steps here. Okay, take it in stride. So before we do anything, you know what? Let's keep flip change this guy. Let's get that KFC right out of the way. I'm kind of hungry anyway, so let's just do that right now. So I'm going to keep the first one, flip the second one, right? Plus 4y plus 1, and change it to multiplication. Okay? So we are all KFC'd out. Okay? Now let's simplify these expressions such that we can get some cancellations and fully finish solving this problem. So I'm going to move this over here. Okay, just because I know I'm going to need some space. So this guy right here, circled in yellow, which you probably can't see, all right, is an example of a difference of perfect cubes. All right, so let me rewrite that guy so maybe you can see it better. 2y cubed minus 3 cubed. All right, we also got, hey, look at that. We got a difference of perfect cubes down below here as well. All right, so let me rewrite this. So I'm going to go 4y cubed minus 1 cubed. All right, and hopefully that kind of guides you when I write it like that to figure out what your a and b value is. Notice I didn't change any value in the expression, and if I cubed both 2y and the 3 and the 4y and 1, excuse me, we would get the same expression. Okay, let's take a look at the other side. This side here, okay, we're going to have to use factor by grouping for this guy, right? This 16 squared plus 4y plus 1. So, do we want to do that there? I don't think so. Let me move this over here. So 16y squared plus 4y plus 1. Okay, and so we're looking at the factors of 16 such that they add up to 4. So we got 4 and 4, 8 and 2, Uh-oh. I'm not seeing any factors of 16, okay, that can add up to a positive 4. So you know what? We're going to leave that expression right there. I think we might see that guy get canceled again here. So just wait. Good things come in patience, okay? And finally, this one down below here is definitely an example of a difference of 2 squares. And so it's going to be 3 plus 2y 3 minus 2y. Okay, so now, oops. Let's simplify this guy here. So we got a difference of perfect cubes. Remember the difference of perfect cubes is a cubed minus b cubed is equal to a minus b, a squared, plus ab plus b squared. Okay, so that is our formula for difference of perfect cubes. Okay, so I'm going to use that for both of those. So in the first case, my a value is a 2y minus my b value, which is 3. Then we're going to go 2y squared, okay, plus 6y plus 9. Down below, 4y minus 1 will be our a and b value. So we get 4y squared plus 4y times 1 is just 4y plus 1 squared, or 1 squared is just 9. Over here, we got the 16y squared plus 4y plus 1 all over 3 plus 2y, 3 minus 2y. All right, and finally, simplify this guy right here. 2y squared is just 4y squared, and 4y squared ends up being, drum roll please, 16y squared. And so that's why it wasn't incredibly important for us to try to simplify that, because guess what gets to go away? All right, so finally, all right, let's get some cancellations here. Now, I really only see one in particular. It's just going to be that guy right there. All right, make sure I keep flip change everything. Yep, everything looks good. Sometimes you got to check your math here. So what do I have left? My answer, which would be quite lengthy, all right, 2y, sorry, having a moment, just making sure everything's correct. So we'd have 4y squared plus 6y plus 9 on the top, and on the bottom we would have these these three expressions, sorry. I feel like I still see one more cancellation. Can you guys spot it? Hopefully you can. It's this guy right here. All right, but mind you, when you cancel it, it becomes a -1. So our final answer is going to be a negative 4y squared plus 6y plus 9 all over 4y minus 1, 3 plus 2y. And there is our answer. Okay, our answer for this one. All right, draw it in there a little better. Okay, let's look at number 15, and we'll call it a DAY. All right, so here we have a rational equation, which means in order to solve this, we need to have common denominators in all three terms. Right? And so I like this x minus 3, and I like this x. And the only common denominator we would have to use here would have to be x and x minus 3, which means I'm going to multiply this side by an x. Over here, I'm going to multiply this side by x minus 3. Right, so plus, this would be 2x. Over here, I'd have x minus 3 times x minus 3 equal to, and on this side, I just need to multiply the top and the bottom by an x. So I get x times x minus 1 all over x minus 3. Okay, so finally, ready to rock and roll here. All right, so we drop the denominator.
Ms. Bickler, please call extension 4423. Ms. Bickler, call 4423.
Everybody catch that? All right. So I'm going to distribute this guy here. So x squared minus x. And get rid of those parentheses because we don't need them anymore. Combine like terms. So I get a 3x minus 3 over here. X squared minus x on the right side. And now we are left with solving a quadratic equation. Okay? So which means I got to bring everything over here. So 3x plus 3 minus 3x plus 3. So I get 0 is equal to x squared minus 4x plus 3. So now we're looking at the factors of 3. Okay, what are the factors of 3 that can multiply to a positive 3 and add to a negative 4? Well, they both have to be negative. And so therefore, we're looking at x minus 1, x minus 3. Set both of these things equal to 0. X minus 1 is equal to 0. X minus 3 is equal to 0. Plus 1, x equals 1. Plus 3, x equals 3. All right, and so the reason why there's two answers is because this is a quadratic, okay? We have an x squared in there, which means, all right, typically you do get two answers, all right? Not always, but in most cases you do. I don't want to say in most cases, but you can get two answers when solving quadratics, all right? And remember, when we're solving quadratics, okay, what we're really finding here, and if you were to put this in your calculator into your y equals, you would see that these 2 points in our graph is where our equation, right, the graph of our equation here, crosses the x-axis. Okay, so it crosses the x-axis at 1 and when x is equal to 3. Again, what's my y value on that line on our x-axis? Well, our y value is 0, right? So that's what we're finding. We're finding when our y value is 0, or what values of x do we have, okay? Now remember, quadratics can look like this. Sometimes they'll look like this, okay? Sometimes they'll only have one solution, which means it'll touch the x-axis just once, or you might have an example where it's just floating out there and it doesn't touch anything. Okay, so just a quick run by of what quadratics are and what they look like. Again, if you don't know what they are, take this guy and put it in your calculator. All right, see what it looks like. Okay, and also look at your table of values and see where it crosses the y-axis. And I guarantee it, you would see it crosses the y-axis, or I'm sorry, the x-axis at those 2 places. Okay, so that is the review. So for homework, I want you guys to try all the even problems. So 2, 4, 6, 8, 10, 12, and 14. Okay, 7 problems. Good luck.